Section 2.3, other types of the graph. So we already talked about the histogram and then the frequency polygons and mosaic in the 2.2. And then we're going to talk about more graphs here. All right, so first of all, we're going to do the bar graphs. Okay, so I don't want you to be confused with the bar graphs with the histogram, because the bar graph represent the data by using the vertical or horizontal bar whose height or length that represent the frequency of the data. Okay, so in the first example, the table shows the average money spent by first-year college students. To draw the horizontal and vertical bar graph for the data. So electronic $728 and dorm decor $344, clothing and $141 and shoes are the $72. Okay, so first graph, I want to make the horizontal bar graph, and the second one I'll put the vertical one. So in order to be a horizontal, we have to have a bar like this, okay? And then for the vertical, we have to put the bar like this, okay? All right, so that's the bars, okay? So bar graph is not the separate as a bar, and then the histogram is connected each other. Okay, so let's do the horizontal graph, okay? So in order to be the horizontal bar graph, we have to put the frequencies on the right. So this is the money that I'm going to put in, okay? So since there's a 228 is a large number, so I think I'm going to go by 1, 2, 3, 4, 5, 6. Okay, I'm going to go by 100, okay? So this is 100, 200, 300, 400, 500, 600, 700, and 800, right? And then it doesn't really matter, but let me put the electronics right here. And then dorm decor here. I think I have a space here, right? Okay, so I'm gonna put the electronic here. And then dorm decor. And then I put the clothing for the third, and then shoes for the last. All right, so the electronics is 728, so a little more than 700, right? So about this bar. Okay, I think it's too long. Gonna make a rectangle, and the dome decor is 344, so about here. And for the clothing, 141, which is this is 200, 141, about here. And then the shoes is a 720, which is 72, sorry, 72. Okay, so we have this kind of the horizontal bar graph. Now the vertical, we're gonna switch the axis, okay? So I'm gonna put that as here as 100, 300, which is, I think I have room to write everything, right? 500, 600, 700. Oh, so I'm missing one, but that's okay. And then all the here, I'm gonna put that as this way, the electronics. And then I put that as dome decor. And then the clothing and shoes. All right, so for the electronics is 728, so bar gonna be about here. And then dome decor 344. And clothing is 141. And then shoes is a 72. Yeah. So those we call the bar graphs, okay? Now Pareto charts is used to represent the frequency distribution for the categorical values variable. And the frequencies are displayed by the height of the vertical bar, which is arranged in order from the highest to the lowest. So important thing is, for the Pareto chart, we can always put the chart has the highest to the lowest, okay? So on example 1, hold on a second, what's going on here? Okay, I don't have okay, I think I have a 2 page of the Yeah, I think I have a 2 page of the first, okay, isn't it? All right, so let me move this one right here. So I already have that graph on the above, okay? All right, so let me do the example here. So per the charts need to be the highest to the lowest. So the data shows and consists of the average number of the hours that a commuter spend in traffic congestion per year in each city. So draw and analyze operator for the data. So there are 5 cities: Atlanta, Boston, Chicago, New York, and Washington D.C. So the hours takes for the commuting is Atlanta is 52 hours, Boston 64, Chicago 61, and New York 74, and the Washington D.C. is 82. Okay. So the suggestion for the drawing the Pareto charts, number one, make the bars the same width, and then arrange the data from the largest to the smallest according to the frequency, and then make the units as a used for the frequency equal size. Okay. All right. So what I have, I want to make that as the highest, which is I want to put the Washington D.C. is the highest number, right? So I put the Washington D.C. is the first place, and then the New York for the second place, and then the Boston for the third place, and then the Chicago is next place, and then the Atlanta. Atlanta, right? Atlanta. Okay. All right, that's the place. And then number is up to the 82. So 1, 2, 3, 4, 5, 6, 7. Okay, so let me put down as I can put down as 20, right? So or 15, 15, 30, 45, 60, and 75, and then 90. All right, I think that's enough. Okay. So for the Washington D.C. is 82. So 80 is about here, right? So 82. Okay. And then the 74 as a New York. So a little bit lower than here. Have to be the same size though. And then Chicago is a 61. More than that. And then the New York is a 74. Oh, sorry. The Boston is the 64, right? Oh, sorry. I have to do the Boston first, isn't it? Sorry about that. So Boston is the 64, a little above that. And then Chicago is a 61. And then Atlanta is 52. So about here. Okay, so we put it, I should have put it in the same size, but you know. A compounded bar graph. Okay, bar graph can be used to compare data for 2 or more graphs, and these types of the bar are called the compounded bar graph. So, which means using a 2-bar graph to compare to the two steps. So, example, consider the following data for the number in millions is never married adults in the United States. So 1960, 15.2 million people and 12.3 million people for the female. 1980, males are 24.2 million and females are 20.2 million. And 2000, 32.3 and 27.8 million. And then 2010 is 40.2 and then 34 millions. So as you notice that the number of the people who's never married been increases, right? All right, so I want to put that as male, female, but I'm gonna put the male as the red. I'm gonna put the red here, okay? So I'm gonna use the red for the male and then the female for the blue, okay? So that makes a difference of the bar, right? Okay, so let me label the mark, okay? So let me label for the 1960, 1980, 2000, and 2010. And then on the other side, the highest number is 40, right? So I think I can go with 5, 10, 15, 20. 25, 30, 35, 40, and 45. I think sounds good to me. All right, so for the male, right? So 1960 is a 15.3. So about here. 1980 is a 24.2. And then 2000 is 32.3. And then 2010 is a 40.2. And then for the female in the 1960s, 12.3. And then the 1980s, 20.2. And then 2000 is 27.8. And then 2010 is 34.0. Okay, so yeah, so that's, you can see the comparison between the two bars in each year, right? All right, now time series graph. The time series graph represents data that occur over the specific period of time. So the data shows the average cost in millions of dollars of the 30-second television on the Academy Award show. Draw and analyze the time series graph for the data. So 2010 was 1.40 million, and 2011 is 1.55 million, 2012 is 1.61 million, 2013 1.65 million, and 2014 1.78 million, 2015 is 1.90 million. So in order to do that, okay, so axis, I want to put that as years, and then cost on the vertical, okay? So 2010, 2011, 2012, and 13, 14, and 15. And then, okay, and on the other side, okay, starting from the 1.0 to the 1.9, so the numbers are very get close to each other. So I want to starting from the, actually, I just ignored this one, okay? So that interval is not same as what we got. So 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2.0, okay? Let me put it this way. And then we're using the time series graph as the segment, as connecting the points, okay? So we're going to plot the points first. 2010 was about 1.40. 2011 is 1.55. 1.61 for the 2012. That's 1.65. And 1.78 for the 2014. And 1.9 for the 2015. So you just need to connect this to see the time series graph. Okay, that's all. Now we're going to talk about pie graph. The pie graph is a circle that is divided into the sections or wedges according to the percentage of the frequencies in each category of the distributions. So this frequency distribution shows the number of the pounds of each snack food eaten during the Super Bowl. So construct the pie graph for the data. So potato chips are 11.2 million and pounds, right? Tortilla chips are 8.2 millions, and pretzels are 4.3 millions, and popcorns are 3.8, and snack nuts are the 2.5 millions. Okay, so we can put that as a degree and percent. So degree is one whole circle makes a 360 degree. Okay, so if you want to put that as a 360 degree, what we're going to do is we need to find out the sum first. So total of the pounds is going to be the 30 million. We need this, okay? And then the degree, which means each of the degree pound millions, right? Pounds divided by total. Then we're going to put that in the degree. So, but one whole degree is a 360. So multiply by 360 degree give us the 134 degree. So we'll do the same way, okay? So 8.2 over 30 multiplied by 360 degree give us 98 degree. And then the 4.3 over 30 times 360 degree give us 52 degree. And then 3.8 divided by 30 times by 360 degree give us 46 degree. And then 12.5 times over 30 times 360 degree give us 30 degree. So overall, it's going to be 360 degree. All right, so since we are using degree, so what I do on the pi or circle, okay, let me actually divide, okay? So this is a 0 degree, and the half is a 180. And then the another 1/4 is a 90 degree, and then the 3/4 are the 270. So I'm gonna actually make the divide 9 sectors: 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Same thing. I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Which means each one is a 10. Okay? So this is a 10, 20, like this. So first of all, we need to find the center. And then starting from the 0, okay, you can start anywhere you want, okay. And then I'm gonna find the 334. So 334 is so 100, 10, 20, 30. So it's about here, okay. So I want to say this is about 134. Okay, so this is gonna be the 134 degree about the potato chips. And then in order to find the tortilla chip sections, now I'm going to add it. So I'm adding the 134 that we have and plus 98, which gives us a 232. So I'm going to find the 232. So which is 180, 190, 200, 10, 20, 32, about here. So about here. So I want to say this is a 232 degree, which is a 98 degree of the tortilla chip. And then from the 232, now I'm adding the 52 degree. So plus 52 give us a 284. So I'm going to find the 284. So 284 means 270 and 80, about 4 here. So this is 284. Which is, this is going to be a 52 degree, which is a pretzel. And then 284, now I'm adding the 46. Adding 46, I have a 330. So 330 is about here. Oh, sorry. What am I doing? It's about here. So which should give us a 46 degree, which is a popcorn. And then we have the one remaining sector, which is going to be the 30 degree. That means the snack nuts. Okay, so that's how I use for the degree. Now the percent, this is how I use. Same thing, we use individual pounds divided by total, but percent is about 100. So multiply by 100. So they give us a 37.3%. 8.2 over 30, now multiply by 100, you'll get the 27.3. And then the 4.3 divided by 30 multiplied by 100 give us 14.3. And then the 3.8 over 30 multiplied by 100 give us 12.7. And then 2.5 over 30 times 100 is give us 8.3%. So now I'm going to use a circle, okay, to get the fill out the pie graph, okay. All right, so what I do is, since 100, so I'm going to put down as here's a 0, and this is actually the 50, right? And then we go back to 100, right? So we're going to make the 10. So 1, 10, 20. Isn't it too small? Okay, let me get that a little bigger, okay? Oh. Okay, so let me say 1, 10, 20, 30, 40. Oh, sorry. Yeah, not perfect, right? 10, 20, 30, 40, 50. Okay. All right. So now from the center, right? So from the 0, and then I'm making a 37. So this is 10, 20, 37. So about here. 37. So 37.3%, which is potato chips. And then now same thing. This is 37.3. So I want to add it 37.3 plus adding the 27.3, 27.3, 37.3, 27.3. So 64.6. Okay, so 60 is right here. So about here. So about here. So this is it. So this is 64.6, which is 27.3% as a tortilla chip. And then 64.6, I'm adding the 14.3, which gave us 79.9, so which is 70.9, it's about here. Okay, so about here. So let's say this 78.9%, right? So which is a 14.3%, which is pecho. And then the 78.9, I'm adding the next one, 12.7. I got 91.6. So this is 91.6. So it's about here. So this is going to be the 12.7%. And then that must be the popcorns, right? And then the rest of them is going to be the 8.3%, which is the snack nuts, okay? All right, so that's all. See, do you see that though? The sector, looks the same, right? Okay. Now, I want to do the dot plot for the next example. The data shows the number of the named storm each year for the last 40 years. Construct and analyze the dot plot for the data. So I have 40 years of the data value, right? So there's a lot, right? So first of all, I want to find the smallest number and the biggest number. Smallest number I can see as a 4. The biggest numbers I can get is 28. So we try to fit that in here. Okay, so in order to fit, I want to say 0. Let's start with a 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I make a 40, okay? So now what I hear, okay, so starting from the 19. So 19 and 19 is right here. So put the dots. Okay, that's we call dot plus the dots. 19, 15, 14, 7, 6, 11, another 11. So put a dot as a stack each other, okay? So 9, 16, 8, 8, and 11, and 9, 9, 8, 16, 12, 13, 14, 13, 12, 7, 15, another 15, and 19, 11, 4, 6, 13, 10, 15, 7, 12, 6, 28, sorry, and 10, and 12, 8, 7, and 12. This is 12, right? And then 9. Okay, so I got this. So this is not the... Okay. All right. So this we call the dot plus. So it shows that the what data is the most, right? Stem and the leaf plot, which is this is the last. Okay, so for this one, the stem and the leaf plot is data plot that uses parts of the data value as a stem and the parts of the data value as a leaf from the groups or classes. Okay, so what I do is there's actually the vertical line, right? You notice, okay, and then separate the two places. Okay, so this part is we call the stem parts, and this is a leaves part. So for the stems, and then the leaves is always a one digit should come out. Okay, so one digit means that this is the last digit. So 25. So 5 is the last digit, and 2 is the earlier piece, right? So what I do is when I look at the number is like a 20. So I want to put the tens on the stem part, and the ones on the leaves part. Okay. So I see the 20, 30, 20, 30. Like I'm talking about this. Okay. 20, 30, 20, 30, 10, 10, 4, 0, 10, 5, 50, 20, 30, 30, 30, 30, 40, 30, 50, 40, 50, 40. So, okay, so I want to put the tens as 0 tens, 1 10, 2 10, 3 tens, 4 tens, 5 tens. And then for the 0 tens, okay, so starting from here, okay, so 25. Oh, sorry, 25. What am I doing? 25 right here. So it is a 25, okay, sorry. 31, 20, 32, 13, 14, 43, 2, 57, 23, 36, 32, 33, 32, 44, 32, 52, 44, 51, and 45, okay? And then we want to actually rewrite it to make the nice ways, okay? So which is stems the stage, but we try to leave in the ascending order, okay? So 0, 2, 1, 13, 14. But 2, instead of the 25, 20, and 30, 23, I want to say 20, 23, and 25. For 3, there's a 20, 31, and then there are 4 32. So 32, 32, 32, 32, and 33, 36. 40 is already in order, right? So 43, 44, 44, 45, 51, 52, 57. Okay, so this is a nice forms to use, okay? All right, I think that's all for this sections, okay? So thank you for listening.